Alright, let's talk about power functions. Power functions are a particular type of polynomial function, and these are polynomial functions that just have one term. So if you look at these examples right here, all four of these polynomial functions, each one has one term: 3x, 8x cubed, negative 3x squared, negative 5x to the fourth. Each has only one term. So we call that a power function. And these power functions fall into two categories as far as kind of the way we can categorize them. And it goes back to the degree of that polynomial function, whether it's, in this case, an odd degree or an even degree. Okay, so let's look at some graphs here, and I'm just gonna just to kind of explore this a little bit. Let's graph a few of these power functions. So start with one we're real familiar with: y equals x squared. Okay. So if I graph that, that's that parabola shape, right? Now I'm also going to graph another power function that's even, because remember I said it kind of depends on if it's even or odd. Let's do x to the fourth. Graph that alongside x squared. And let me actually zoom in there at the origin. Okay, there's x squared, and there's x to the fourth. Let me just do, let's go ahead and just do a couple more. Might as well do x to the sixth, and let's do x to the eighth. Okay. Now you should kind of notice that these graphs all have sort of the same shape. All of those, you'll notice all of those even power functions have that same U shape. They're sort of like parabolas, but they start to flatten out more and more as that power gets higher. But again, they all have sort of the same shape, right? X squared, x fourth, x to the sixth, and x to the eighth all look about the same. And of course we can add in like a negative sign. We should know what that does. Okay. If I make one of them negative, doesn't that just flip it over, right? Doesn't really change the rest of them. But what we get from that, even power functions open up in a U shape. Okay. Now, odd power functions. Now, if you know and can think about what we know about x cubed, that graph, that cube function, we know it looks like this. So one might assume, what would x to the fifth look like? It's also sort of an S shape. Okay. But again, it's a little bit more flattened out. If I do x to the seventh, let's do x to the ninth, just get several examples up here. You'll notice they all kind of look the same, but the higher that exponent gets, the flatter it gets. Okay. And so just basically look at all those graphs just to say that the even power functions look the same and the odd power functions all look kind of the same. Alright, it's pretty simple to see that. Okay, so we can now use that and graph polynomial functions using some transformations. And so let's graph f of x equals 1 minus x to the fifth using the transformations we learned about in that last chapter 3, section 3.5. So what would that look like? Okay, well, we're starting with, if we switch this around, what's our base graph we're starting with? That's x to the fifth, right? So x to the fifth looks something like this. Okay, that's like that S shape. But what are we doing to that graph? Okay, we've got a negative x to the fifth, right? So what did that negative sign do? Didn't that flip it about the x-axis? Okay, so it's gonna actually be coming down like this now. And actually we've got one other thing here. We also have the +1 would be a vertical shift up 1, right? So we're talking something sort of like this. Okay, this is x to the 5th. Here this is negative x to the 5th plus 1. Okay, we have a reflection about the x-axis and then also a vertical shift up 1. And we can definitely check that just to be a little more confident with our answer. If we just look at the graph of 1 minus x to the 5th, whoops. Hopefully it looks something like that graph we just drew. Okay, obviously not exactly like it. Mine was more of a sketch, but really the idea is that you know what sort of the shape of that graph is going to look like. If you want an exact graph, you can always look at the calculator and get an exact graph, but started out like this, flipped it, bumped it up 1, and got this. Okay, 1/2 x minus 1 to the 4th. Again, what's our base function we're working with? That would be x to the 4th, right? And what have we done to it? We've got an x minus 1. And so that would be a horizontal shift. That's going to go up. I'm sorry, not up. To the right 1. And the 1/2 is going to be a vertical compression, right? And so we did have x to the 4th being like a U shape. This is x to the 4th. We're going to shift it to the right 1, and it's going to be flattened a little bit more. Okay, so it's going to look something like that. Again, this is just a rough sketch, and you know, with what we're going to be doing, if you have your calculator, you can get a really good picture of this. So just again to verify the shape of that graph we just came up with, 1/2 times x minus 1 to the 4th looks like this. So shifted to the right, if we want to compare that to our original graph, x to the 4th, you'll notice it's shifted to the right and it's compressed just a little bit. Okay, maybe hard to tell that this one right here just a little bit flatter than this one right here.